Hello students, how are you doing today? Today we will start with yet another session of chapter 15 probability, but today we will do a lot of questions based on this topic. Before that, let us recall what we had studied in our earlier session. We had studied the difference between experimental probability and theoretical probability. We know that experimental probability depends on a large number of trials of an experiment, and theoretical probability is based on possible outcomes of an experiment. We know that the difference between the experimental probability and theoretical probability is nothing but that the experimental probability depends on large number of trials of an experiment, and theoretical probability is based on possible outcomes of an event. The formula for finding probability of any event is nothing but number of favorable outcomes divided by the number of all the possible outcomes. We know that the sum of probabilities of all the outcomes of an experiment is 1. We studied what are complementary events. If E is an event, then its complement is denoted by E dash, and the sum of probabilities of complementary events is 1. Then we had studied that the probability of an impossible event is 0. Does the sun rise in the west? No, we know for sure that the sun rises in the east. So this is a sure event, and what is its probability? The probability is 1. Thus the probability of any event lies between 0 and 1. So now it is time to practice. Let us do the first question. A bag contains a red ball, a blue ball and a yellow ball, all the balls being of the same size. Kritika takes out a ball from the bag without looking into it. What is the probability that she takes out the yellow ball, and second part is red ball, and lastly the blue ball? So let Y be the event of taking out a yellow ball, B be the event of taking out the blue ball, and R be the event of taking out the red ball. So we use the formula PE equal to number of all the favorable outcomes upon the number of all the possible outcomes. So since we have 3 balls in the bag, yellow, blue and red, so the possible outcomes is 3, and the number of favorable outcome of taking out the yellow ball is 1. So what is our probability? The probability of taking out a yellow ball is number of outcomes favorable to Y and number of divided by the number of all the possible outcomes, which is nothing but 1 upon 3. Similarly, the probability of taking out the red ball is 1 upon 3, and probability of taking out a blue ball is 1 by 3, and this is our answer. Let us proceed to the next question. 2 dice are thrown at the same time. Find the probability of getting the same number on both dice, and second part, different numbers on both dice. This is question number 19 of exercise 13.3 of NCERT exemplar book. So let us see, when 2 dice are thrown at the same time, what are the possible outcomes? In this diagram you may come across dice in which the number on the first dice would be 1 and the number on the second dice would be again 1. Similarly, if it is 1 on the first dice, it can be 2 on the second dice. Likewise, continuing in this manner, we may get all such possible outcomes. So how many are these? Let me just write this table into a number format. So we may get all such possible outcomes. How many are these? So these are, if you count these outcomes, these are 36 in number. So the number of all the possible outcomes is 36. So now let us solve the first part. Let E be the event that same number appears on both the dice. Okay. So what are the favorable outcomes? So we have the favorable outcomes as 1 1, 2 2, 3 3, 4 4, 5 5 and 6 6. Why? because 1 appears on first dice and the same number 1 appears on the second dice as well. So this is true for all numbers till 6. How many are the favorable outcomes? We have, if you count these outcomes, we have favorable outcomes as 6 in number. Okay. So we apply the same formula, that is the number of favorable outcomes upon the number of all the possible outcomes, which is PE equal to NE upon NS, and the favorable outcomes are 6 and the total possible outcomes are 36. So this is, probability is 6 by 36, which is equivalent to 1 by 6, and this is our answer. Isn't that easy? Let's solve the second part. Let F be the event of getting different numbers on both the dice. Okay. So we will find the favorable outcomes. What are the favorable outcomes? We know that total outcomes are 36, and in the first part we had found the favorable outcomes as 6. That means these favorable outcomes were for the same number appearing on both the dice. So what do? We subtract 6 from 36 to get favorable outcomes as 30. So the favorable outcomes for the event of getting different numbers on both dice is 30. We apply the same formula, that is the number of favorable outcomes upon the number of possible outcomes for finding the probability, which is 30 upon 36 and which is equivalent to 5 by 6, and this is our answer. Let us proceed to the next question. 2 dice are thrown simultaneously. What is the probability that the sum of the numbers appearing on the dice is 7, prime number, and third part is 1? So let us read once again. 2 dice are thrown simultaneously. So what is the sample space? In earlier question we looked that the sample space of throwing 2 dice is 36. This is the sample space, and what are the total number of possible outcomes? The possible outcomes are 36. What is the probability that the sum of numbers? Important phrase is sum of numbers. Okay, remember this. Sum of numbers appearing on the dice is 7, prime number, and 1. So let us solve the first part. Let E be the event that sum of numbers appearing on both dice is 7. In this sample space, in this table, I have highlighted the sum of numbers for your understanding. For example, if 1 appears on first dice and 6 appears on second dice, what is the sum of numbers? It is 7. Similarly, 2 plus 5 is 7, 3 plus 4 is 7, 4 plus 3 is 7, 5 plus 2 is 7, and 6 plus 1 is 7. So these are our favorable outcomes. How many are these? If you count these are 6 in number. So the favorable outcomes are 6 in number, and we have written NE equal to 6, which is number of events that the sum of numbers appearing on both sides dice is 7. So NE equal to 6 and number of possible outcomes is 36. We will apply the same formula for finding probability, and we get that 6 upon 36, which is equivalent to 1 by 6 as our answer. Let us solve the second part. Let E be the event that the sum of numbers on both the dice be a prime number. So notice that we need to find the probability of sum of numbers to be a prime number. Okay. If we go back to the previous slide and refer to this table, we need to find those outcomes whose sum is a prime number. So see here, 1 plus 1, is it 2? So this is a prime number, so we will mark this. What about 1 plus 2? 1 plus 2 is 3, which is again a prime number, so this is a favorable outcome. What about 1 plus 3? This is 4. This is not a prime number, so we will leave it. What about 1 plus 4? This is 5. This is again a prime number. This is the favorable outcome. So in this manner, we will mark all the favorable outcomes in this table, and if we go to the next slide, I have written all the favorable outcomes for you. And how many are these? These are 15 in number. Let us calculate the probability. Again, the same formula, number of favorable outcomes upon the number of all the possible outcomes, which is 15 upon 36. Whenever two dice are thrown, our possible outcomes remain the same, that is 36. I have drawn the table in every question for your understanding. You need not draw this table every time, it will save a lot of time of yours. So 56 is equivalent to 5 by 12, and this is our answer. Let us solve the third part. Let E be the event that sum of numbers on both dice be 1. Again refer to this table. Please see this table carefully. Can you find any of the outcome in which the sum of numbers is 1? I don't think so. Why? Because there is no outcome such as which says 0 1 or 1 0. So this is a case of impossible event. We cannot find any number, any outcome whose wherein the sum of digits is 1. It has to be greater than 1. So what is the probability of an impossible event? This is 0, and so 0 is our answer. Isn't this very easy? Let us move to the next question. Two dice are thrown together. Find the probability that the product of numbers on top of dice is 6, 12 and 7. So in this question we need to find the probability of product of numbers. Okay. So let us refer to the table. So again two dice are thrown, so we have the sample space like this, in which the possible all the possible outcomes are 36. Let us solve the first part. So all the possible outcomes we denoted by S, and which is equal to 36. Okay. So our first part, let E be the event such that we get the product of numbers, product as 6. So we need to find the favorable outcomes. What are the favorable outcomes? See, favorable outcomes, first of all it would be this one. Why? Because 1 into 6 is 6. Then the other one would be 2 3s are 6. Next it would be 3 2s are 6. And last it would be 6 1s are 6. Can we find any other favorable outcome? Let us see in the table. No. So these are our favorable outcomes. Let us write these. How many are these? These are 4 in number. So we get the number of favorable outcomes as 4, right? What is our required probability? We use the formula PE equal to NE upon NS, which is equal to 4 by 36, and this is equal to 1 by 9. Why? Because 4 9s are 36, and this is our required answer. Got it? Let us move to the second part. So let us solve the second part. So we need to find the probability of product of numbers on the top of the dice such that the product is 12. Okay. So let us mark in this table. First of all, it would be 3 4s are 12, 2 6s are 12, 4 3s are 12, and 6 into 2 12. So we have favorable outcomes as these. Let us write these. First of all, let E be the event that the product of numbers is 12. So what is our sample space? Sample space is 2 6, 3 4, 4 3, and 6 2. And how many are these? So we have n equal to number of favorable outcomes equal to 4. What is our required probability? The required probability is PE equal to number of favorable outcomes upon the number of all the possible outcomes, and this is equal to 4 upon 36 equal to 1 by 9. And this is our required answer. Did you understand? Let us solve the third part. In this, we need to find the probability such that the product of numbers is 7. Okay. So let us write these. Again, we consider E to be the event such that the product of numbers is 7. Again, have a look at this table. Can we find any outcome wherein the product of numbers is 7? Let us look it carefully. I don't think so. Can you? No. So what is a favorable outcome? Nothing. As in, the favorable outcome is 0. Why? Because this is an impossible event. We cannot find any outcome wherein the product of numbers is 7. Okay. So this is an impossible event, and what is the probability of an impossible event? Yes, you are right. It is 0. And this is our required answer. Simple as that. Let us move to the next question. A coin is tossed 3 times. List the possible outcomes and find the probability of getting all heads, at least 2 heads, and last part, at most 1 head. We again read this question. A coin is tossed 3 times. Now we have a coin. Visualize yourself. A coin is tossed 3 times. 1, 2 and 3. Okay. Let us understand with the help of a diagram. On the first toss we get either head or tail. On the second toss, if we are getting head on the first toss, then on the second toss we can get head or tail. Similarly, for tail we can get head or tail, and for the third toss we can get all these possible outcomes. So, what are the possible outcomes? On the first toss, if we get head and then again we toss a coin, we again get head, right, and again we can get head or tail. So, the first outcome would be head, 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 which is this. Then the second outcome would be head, head, tail, which is this. Third outcome would be head, tail, head, and fourth one would be head, tail, tail. Similarly, if we get tail, we would get all these outcomes. Okay. Let us write our sample space. On the first toss, if we get head, second toss we again get head, then third toss we again get head. Similarly, we can get head, head, tail. All these are possible outcomes. How many are these? Let us count. 1, 2, 3, 4, 5, 6, 7, 8. So, the number of all the possible outcomes when we toss a coin 3 times is 8. We write it as NS equal to 8. Okay. Now, let us solve the first part. We get all the heads. Let E be the event such that we get all heads. That means, what is our favorable outcome? This is H, H and H. Any other? You have all the possible outcomes here. Look at these. So, the number of favorable outcome is 1. So, what is our probability? This is probability of the event upon NE upon NS, that is number of favorable outcome upon number of all the possible outcomes. Okay. And this is equal to 1 upon 8, and this is our required answer for first part. Let us move to the second part. So, let E be the event that we get at least 2 heads. At least 2 heads. What do we mean by at least? At least means 2 or more heads. Okay. So, what is the favorable outcome? 2 heads HHT, HTH, THH, and HHH. At least 2 outcomes. Remember, 2 or more heads. 2 or more heads means 2 heads in these outcomes and 2 or more, that means 3 heads in this outcome. So what is the number of favorable outcome? We have NE equal to 4, and what was NS? NS was 8. So what is the required probability? Required probability is PE equal to NE upon NS, which is equal to 4 upon 8, and this is half, right? And this is the required answer. Okay, did you understand? Let us go to the third part. We need to find the probability of getting at most one head. Let us solve this. So E be the event of getting at most one head. Now, what does at most mean? At most means 1 or less. 1 or 0 head. So what are the favorable outcomes? Let us see. We just need one head. Lastly, 0 head, that means all the tails. Okay, so we have NE equal to 4, right? And the required probability NE equal to, sorry, PE equal to NE upon NS, which is equal to 4 upon 8. Remember all the possible outcomes as 8, right? You can count these, and this is equivalent to 1 by 2. Correct? Let us move to the next question. It says the king, queen and jack of clubs are removed from a deck of 52 playing cards, okay, and then well shuffled. Let us read this again. The king, queen and jack of clubs are removed from a deck of 52 playing cards and then well shuffled. Now one card is drawn at random from the remaining cards. Determine the probability that the card is a heart, a king, a club and the number 10 of hearts. So we already know that a deck of 52 playing cards has 4 suits: clubs, spades, hearts and diamonds, and each suit has 13 cards, right? So that makes 52 cards. The question says the king, queen and jack of clubs. So here we have clubs suit and these 3 cards are removed. Okay. How many are left? So the number of cards we have is 52 minus 3, which is equal to 49 cards. remember this number 49 cards. The total possible outcomes are 49. Okay, let us solve the first part. E be the event that we have a heart. Okay, a heart means we need to have one heart out of these all the 13 cards. So what are the favorable outcomes? So the number of favorable outcome is 13, right? Since we have 13 cards of hearts and all of the cards are there. Okay, so what is the required probability? Number of favorable outcomes upon number of all the possible outcomes, which comes to 13 upon 49. This is your answer. Very easy, right? Let us solve the second part. We need to find the probability of drawing a card such that it is a king. So we don't have these three cards, right? We know all the possible outcomes as 49, right? We found it earlier in the first part. Now, how many kings are there? There are 4 kings of clubs, spades, hearts and diamonds. But the question says we don't have king, queen and jack of clubs, right? So I have removed it for you. So how many are left? Only 3 kings are left, right? So the favorable outcome is 3. So what is the required probability? It is very simple. Number of favorable outcomes upon number of all the possible outcomes. That means 3 upon 49. This is the answer. Okay, that was quite easy. Let's move to the third part. We need to find the probability that the card drawn is a club. What is a club? Where is the club? Club suit is here, out of which we don't have these 3 cards. Question says so, right? So how many cards are left? We just have 10 cards of clubs suit. So if E is the event of drawing a club card, then the number of favorable outcomes is 10, right? And the number of all the possible outcomes, it remains the same, 49. So our required probability NE upon NS equal to 10 upon 49. Very easy. Let's move to the fourth part. Remember that we don't have these 3 cards, and 10 of hearts is this one. So let E be the event of getting 10 of hearts. So what is the number of favorable outcome? Very simple, it is just 1. And what is the required probability? PE equal to number of favorable outcomes upon number of all the possible outcomes, which is equal to 1 by 49, and this is our required answer. Okay, understood? With this question, we end today's session. I hope you understood it well. Practice as much as you can and come out with flying colors in your exams. All the best, students. Thank you.